Mountains Are Made by Kathleen Widener-Zofeld, illustrated by James Graham Hale. We live in a little town in a valley. There are mountains all around us. On Saturdays, sometimes we go mountain climbing. We follow a trail through a thick forest. At first, the climb is easy. Then it gets steeper and steeper. We stop on a rock ledge halfway up and eat our lunch. When we start out again, we have to walk more slowly. The slope is getting very steep. The forest is thinning out and the trees are shorter. We can see the top of the mountain, but it seems to take forever to get there. When we reach the top, we can see out in every direction. There are hardly any trees up here and the land is rocky. We spend a long time looking at the rocks. Here's one with the shape of a seashell in it. Cool, it's a fossil. Fossils are the remains of animals that lived millions of years ago. This mountain is more than 4,000 feet high. That's nearly a mile. There are no oceans up here. How did a sea animal get to the top of this mountain? The highest mountain in the world is Mount Everest in Nepal. It is 29,028 feet high. That's almost 5.5 miles. But fossil seashells have been found on Mount Everest too. Our mountain is less than 1 mile above sea level. Mount Everest would be about this high compared with our mountain. Here's sea level. The deep sea plains are between 2 and 3 miles below sea level. Millions of years ago, Mount Everest was not a mountain at all. It was part of a flat plain under an ocean. Our mountain was part of a flat plain under an ocean too. All sorts of sea animals lived right here. But that was a long, long time ago. Many changes have happened since then. The earth is always changing. Old mountains disappear. They are worn away by ice, rain, and flowing water. New mountains form where there were no mountains before. We can't see the changes happening, though. Mountains are built up and worn down gradually over hundreds of millions of years. When we look at the earth, all we see are rocks and soil, and the trees and other plants growing in the soil. But if we could look inside the earth, we would see that it is made up of different layers. The surface of the earth is the first layer. It is made of the soil and the rocks we see around us all the time. Just under the surface is a rocky layer, about 35 miles thick, called the Earth's crust. Beneath the crust is a layer of rock called the mantle. The crust and the upper layer of the mantle together form a hard outer shell called the lithosphere. Here's the lithosphere, the crust and the upper layer of the mantle together. The lithosphere is broken into pieces called plates. The plates are huge. There are 8 major plates and several smaller ones. The United States, Canada, and Mexico are together on one of these plates, the North American plate. Europe and Asia make up another. Under the outer shell is a layer of hot, partly melted rock that is softer and can flow slowly like honey. The rock plates float on top of this mushy layer. The mushy layer contains some molten rock called magma. The plates move slowly over the mushy layer, just a few inches a year. The Earth's plates are always in motion. They have been moving for hundreds of millions of years. Most scientists believe that all the mountains on Earth were formed by slow movements in the Earth's outer shell. But mountains in different parts of the world look very different from one another. Here's folded. Some have sharp, pointy peaks. Others are more rounded, so that'd be dome. Fault block. Still others are block-shaped and volcanic. A few are shaped like tall cones. That's because in different parts of the Earth, the outer shell moves in different ways. In some places, two plates press against each other. The tremendous pressure forces the crust to lift and fold over itself. Scrunch. Folded mountains. Great waves of rock are pushed up. Ice and water cut through the folds to form sharp, craggy mountains. If you have a heavy dish towel or hand towel, you can see how this folding happens. And we saw it with our kinetic sand when we did the convergent boundaries. Lay a towel out flat on a table. Put the palms of your hands down, one on each end of the towel. Then slowly slide your hands toward each other. Scrunch. The folds and ridges that appear in the middle of the towel are like the folds and ridges that form giant mountains when two plates press against each other. In other places, pressure deep within the earth pulls and stretches the crust. The stretching sometimes causes long cracks or fault lines to cut through the crust. Stretch. Here's the faults. Crack. Fault block mountains. The crust on one side of the crack may slide slowly upward, while the crust on the other side pushes downward. Block-shaped mountains are formed this way. Sometimes the crust does not fold or crack. Sometimes magma pushes through a vent in the solid rock layer. It collects in a pocket under the crust. The pocket of magma grows larger until it bends the crust upward. When this happens, a high dome is formed. Rain and ice wash away the softer rocks above, and rounded peaks and valleys appear. Here's dome mountains, a pocket of magma. In a few places on Earth, plates are moving away from one another. This usually happens deep under the oceans. Magma pushes up through the space between the plates. Underwater mountain range. When it hits the cool ocean water, the magma becomes solid. Great underwater mountain ranges are built up. Once in a while, a small crack or vent forms in the lithosphere, sometimes right in the middle of a plate. Red-hot magma pushes up through the crack. When it gets to the surface of the Earth, the magma cools and hardens. Once magma reaches the surface, it is called lava. Lava and ash build up around the crack, making the land higher and higher. A cone-shaped volcanic mountain is formed. Most volcanic mountains are formed in places where one plate pushes under another. As the edge of one plate sinks, it heats up. The solid rock of the plate's edge melts in the intense heat. The melted rock or magma rushes up through weak places in the crust above. In fiery blasts, lava is thrown onto the Earth's surface. It cools and hardens, and mountains are built. Volcanic mountains. Some mountains have been around for hundreds of millions of years. Others are still being built up right now. The mountain we climbed is an old mountain. The fossil we found can tell us a lot about how old our mountain is. Scientists have a special way of telling the age of a fossil. This one is nearly 280 million years old. That means this sea animal was actually swimming here 280 million years ago. It died, sank to the bottom, and was buried in sand and mud. It must have been buried sometime just before our mountain began to be born. So, we know that the land here began to rise around 280 million years ago. From the shape of this mountain, we can tell it was formed by the folding of the crust. Remember, like a towel. Two huge plates slowly pressed against each other. The land rose higher and the sea disappeared. Over millions of years, the crust folded up in tremendous waves. This mountain and the other mountains around our town were once much higher than they are now. They were sharp and craggy. Now they are lower and smoother. For millions of years, rain, ice, and flowing water have worn our mountains down. Millions of years from now, the rain, ice, and flowing water will have worn them down completely. So here's what it looked like millions of years ago. Here's what it looks like now. And here's what it might look like millions of years from now. There will be no mountains here. Mount Everest is a younger mountain. It is still sharp and craggy, and it is still being pushed up higher. Mount Everest may be growing as much as 2 inches every year. We're not going to try to climb Mount Everest. This mountain was high enough for us. The Hawaiian Islands are volcanic cones that have pushed up from the ocean floor. They are folded mountains formed millions of years ago when the African plate and the North American plate pushed against each other. So that's the Appalachians. The Appalachians are the oldest mountains in North America. She's pointing over here. The Brooks in Alaska, the Canadian Rockies, and the American Rockies, and the Sierra Madre in Mexico are all part of one long mountain range formed by a mixture of folding, faulting, and volcanic activity.